So you may be used for that this recording also. Let's we go ahead on that learning. One of the topic is called the precision rectifier. It is one of the last topic in the unit. Okay, it is only 4 topic only there in the unit. Already we were discussed about the first one is off wave rectifier. Only half of the period only it is a it will go to working. Remaining half of the period is 0. That is called a half wave rectifier. Then second one is a full wave rectifier. Either you can go for the bridge type of the rectifier, or second one is a center tap type of the rectifier. You can go ahead on that one. Then third one is a 3-phase full wave rectifier. We were seen discussed about that one. The last one of the topic is a precision rectifier. Why it is a precision? Why it is a precision? It is called a name as a precision. What is a precision? So let's we go ahead on that one. That one you will go to learning outcomes. Okay, first one, off wave rectifier. What is the off wave rectifiers? What you were discussed, what you were seen in yearly one, off wave rectifier and their drawback. That one I have shows in the PPT slides. Okay, see that there is a circuit diagram of the off wave. Okay, what is the waveform? Only half of the magnitude only conducted. Why only half of the magnitude is conducted? When top is a pace with respect to neutral, during the condition what will happen? So power is a flow this direction, current is a flow, the circuit is closed. Okay, so top is a pace with respect to neutral, past off cycle. Okay, from that one power is a flow, here supply to that diode to the load to the source. So circuit is closed. Okay, whatever the same source, okay, it will going to come as an output. During the negative off cycle, top is neutral with respect to the pace is a bottom. So pace is a flow, pace to the load, okay, or load to that. Here is a reverse bias. Diode is opposite direction, current is coming. So it is an open circuit. So the current is stay up to this point. Okay, current not move to this point. If it is a form the closed circuit, then the current is a flow. So it is open circuit. So it is a not conducted during the negative of the cycles. Okay, coming to that one. Okay, during the positive off cycle, okay, the diode is conducting. So due to the conduction of this diode, okay, the diode it will going to take this some voltage drop. Okay, it will going to consume something. That's why one of the example I said already. So your father is giving 50 rupees. So ask you to give to your sister on the 50 rupees. Your father are giving 50 rupees. Ask you to give 50 rupees to your sisters. But what you are doing? You are taking for that 7 rupees. So remaining 43 rupees only you are giving to that your sisters. That is what about that one. But that 7 rupees is a it's a transmission charge. You are collecting as a transmission charge. So like here is a drop 0.7 voltage, 0.3 voltage or 1 voltage. For example, German diode means 0.3 voltage. For example, a silicon diode means 0.7 voltage. Other diode means it is a 1 voltage drop. Okay, that is the name is called the threshold. So due to this threshold, so 0 to 0.7. Okay, if I consider as silicon, so 0 to 0.7, does the diode is conducted means no. Does the current is a flow to here? No. So no output voltage. That is called a V0, V out. No output voltage with respect to input. Input is there, but output is a 0. So from 0 to 0.6, and after 0.6, after that what will happen? Threshold once finished, so the current is a flow. So that's why the linearly increasing. So 0 to 0.6 or 0.7, it is not conducted. That is called the threshold with respect to the diode. So that threshold also it is I needed. It is important for me. Why it is important? For example, my application, small signal conditioning, small signal type of conditioning using demodulation type of the signals operations. When I will going to use that a small 0.6 also important. Why it is important? Sometimes my sources, because it's a small signal condition, my source is very less. For example, my source is a 1 voltage source. My source is a only 1 voltage, or my source is a only for that one is a very okay 0.9 or 0.8 during the situations. So in that conditions, okay my voltage okay, my source is a 0.5. So here is a drop is a 0.7. That is a very difficulties. But then what is the load? So nothing. So your father is giving for that one is a 0.7. Okay, ask to give to your sisters. But what about you? Your drop is a 0.7. So directly you will going to consume. So nothing you will going to give to your sisters. So that one avoided purpose. So we are going for that one is a precision. I needed that one also. Simple to say, okay, your father is decided, okay, to stop your consumption of the money. So he want to stop your consumption of the money, that's all. Okay, so that's why you have go for the precision, that's all. This is the objective about that, going for precision. Coming to the point, how to make the circuit? Very simple. Take this circuit. What is this circuit? Half wave rectifier. Yes, same circuit. So here between the source and the diode, so here is the, I will going to make one, okay, I will going to make one circle. I mean that it means I will going to connected one amplifier, operational amplifier, that's all. See, so here is a, I will going to open it and I connected one operational amplifier as I got connected. That's all. Once I got connected, okay, the circuit is a come as a precision rectifier over. That's all. See, here is a ground, or here is also I got connected. It's nothing but it is a connections. Okay, are simple to make the connection ground. That's all. What is this? This is a look like in that side is a minus plus. There are two input and one output. So this is nothing but it is called as an operational amplifier. Okay, there are so many amplifier. What is this type of amplifiers? So minus plus is there, differential amplifiers. So you will going to learn about what is meaning of minus, what is meaning of the plus in the forthcoming of the unit. So here is the, you will going to use this one of the differential amplifiers. Okay, that's all. So here you will going to make and inserted one operation amplifier. It's a, that's all over. The next one. Okay, what about the output voltage of this operation amplifier? Do you know? So this output voltage of this amplifier is nothing but the gain. So here is a op-amp consists of the gain. The gain multiply difference of the input voltage. So G multiply, open the bracket, V1 minus V2. There are two inputs. So V1 minus V2. Okay. See here, source is connected to that plus. So V1 is a plus minus V2. So gain multiply difference of the two input, that is called output of the here point. That's all. When you are using this precision rectifier, it will start from the origin. See the transfer characteristics, it is start from the origin. That's all. So this is a purpose you are going for the precision rectifier. This is a circuit diagram. Next, what we want to see, very simple mode diagram. So mode diagram means what? So operation diagrams. How it is operated here also there are two modes. Mode 1 is a phase with respect to neutral. Mode 2 is a neutral with respect to the phase. So like there are two mode of operations. So mode 1 top is a phase with respect to neutral. So when it is a mode 1 is operated at the condition the diode is on. It's very simple. So keep with the note and then you will going to start to write. Okay, because I don't like to make it for that uninterested. Very simple and start to explain you. So mode 1, mode 2 condition, only two mode of operations. As usual, phase with respect to neutral. Here is what about neutral with respect to phase. Here is neutral with respect to the phase. Ground is the phase. So like, or simple to say it is greater than 0, mode 1 condition, mode 2 condition less than the 0. Input voltage is greater than 0, input voltage is less than 0 during the mode 1 condition. Okay, so here is the diode is on condition. During the mode 2 condition, diode is off conditions. What about the output voltage? That is only things you will going to find out. So what is output voltage? Output voltage it is equal to input voltage. Output voltage it is equal to input voltage. Continue. Yeah. So mode 1, mode 2. What is the mode 1? Phase with respect to neutral. Mode 2 is a neutral with respect to phase. That is the things are simple to say. Mode 1 is greater than 0. Mode 2 is a less than 0. During the mode 1 condition, what about that one? Diode is on condition. During the mode 2 condition, what about the diode is off condition? Why diode is off conditions? When you have see reverse bias. Why it is reverse bias? So neutral with respect to the phase. So phase is a flow to the load. It is a opposite direction. Already you I said about just now also. Off wave rectifier not conducted on the negative off cycle. So reverse bias. So it is a diode is a reverse bias. So 0 output voltage is 0. So no input is a flow to that output. So output is a 0. The circuit is a open circuit. What about mode 1 conditions? Mode 1 conditions, what is there? Okay, I will going to show you one more diagram for explanation about mode 1. This is the mode 1 diagrams. What about mode 1? Mode 1 conditions. Okay, this is there are two input V plus V minus. So comparison of that one, here I have written equation number 2, you can look it V plus minus V minus. This is the difference of the input voltage multiply gain. This is written as an gain. So it is equal to V naught dash. What is V naught dash? In the operation amplifier output. That's why I said yearly output voltage of the operation amplifier is equal to gain. Excuse me. Gain multiply difference of the two input voltage. Yes, that is the equation number 2 is written. The next one. Okay, so here is the coming, and then what is the drop of the diode? 0.7. So it is equal, it will go to, your father is giving 50 rupees, it is equal to, you are consuming the 0.7 and giving the 43 rupees to your sister. So 0.7 voltage you took the amount plus remaining amount you gave to the your sister. So your sister has, she has the amount 43 rupees plus your amount 7 rupees. The summation of this amount is who gave that amount, that is the summation of this amount is given by your father. So V naught dash, who's the here is the operation amplifier. So operation amplifier output is the V naught dash, that's all. So in the equation number 2 I will need to substitute the V naught dash of the equation number 1. So taking this equation substituted, yes, so the gain is, I move to the opposite side, denomination, it is equal to V plus minus V minus. Whenever you have see that one, so top is the lower value, bottom is the gain is higher value. So due to the higher value of the gain, so what about that one? So here is the higher, so your answer is the become a 0. So 0 it is equal to V plus minus V minus, or V plus it is equal to, move that side, V minus. So V plus it is equal to V minus, or you can simple to say input voltage it is equal to output voltage. So during the mode 1 condition, input voltage it is equal to output voltage. What about here? Input is a greater than 0. What about mode 2 condition? Input is a less than 0. Diode is reverse bias, output is 0s. Then you will going to draw the waveform. So input mode 1 conditions, okay, it is a what about that one? Output is equal to the input. Output it is equal to the input. The same waveform you will going to off wave rectifier waveform, so you will going to get. So this is a mode 1. What about mode 2 condition? Mode 2 output voltage is equal to 0. So you will going to get it on that 0. So like you will going to draw the input and the output of the input is the, it is a what is that one, blue color, and output is a yellow color. I have drawn about that ones. Yes. So this is about the precision rectifiers. Okay, what is the drawback of the precision rectifier? There are two drawback, you can say. The major drawback is it is highlighted in that red color. It is a limit the maximum operating frequency. It is not suitable for 50 to 100 kilohertz ranges of the frequency ranges. It is not suitable. So it will going to not suitable. Why means it will going to get the distortions. So it will going to get the distorted. So that's why it is not suitable for higher ranges of the frequency. And what is the second limitation? Second limitation is the smallest one. What is that one? Mode 1 condition is a phase with respect to neutral. Mode 2 is a neutral with respect to the phase. Mode 1 is a phase with respect to neutrals. So during that it will going to changes one phase to another, one mode to another. So mode 1 condition positive V saturation, mode 2 is a negative V saturation. Again mode 1 condition go positive V saturation. So when it is changing means it will going to take some time. It's taking time to move from that negative saturation to the positive saturation. It's taking some time as well. So that is one small limitations. So biggest limitation, it is the not suitable for that higher ranges of the operating frequency. That is the limitation. Then what is the solutions? Then you can go for that modified precision rectifier. Then only you can go for that modified precision rectifier. So here, so I would like to stop here. So precision rectifier, what is that one? Summary of the precision rectifier. So precision rectifier used to minimize that one, or it is a totally eradicated the threshold voltage drop on the diode rectifiers. That is 0.07 also I needed. Why I needed? Because my application is signal conditioning application, demodulation type of the applications. During the situation, that one also important. For example, my source is a lower than that diode drop. So the type of application is not suitable. then what to do? You can go for precision rectifier.